Okay, I've had a lot of comments on my YouTube channel on different videos. One of the big questions was, number one, can we have a closer look at the quality of some of the prints that you're doing? They also wanted to know what type of filament I was using, how I was able to get good prints. Well, and my answer to that was I was lucky, but I was just kidding. Everybody has bad prints. So to start with, I'm going to show you a few of the bad prints that I've had and give you an explanation for it. Number one, these taller parts here, as you can see, had a little bit of a problem toward the end of the process. So these are definitely problems when your printer crashes at that stage of the game. In addition to that, we also had some offsetting, and this is caused by different things. You can see it had an offset in this print and had to stop it. A lot of times problems like these are caused from losing adhesion to the bed and the part starting to move. Especially taller parts, I had problems with some of those initially. Here's a part. You definitely can see some stringing there, I'm sure. These are prints, and I'll print them and get stuff like this, and then I'll go back and make adjustments to speed, retraction, temperatures, and so forth to correct things like that. Also, here's a print that settings weren't good on and I wasn't getting a good quality. I have another example here. That's an adhesion breakdown. This part actually was a part that I had here, and if you look, you can see a difference. I've reinforced this quite a bit and tested it and no longer have that problem of breaking this arm off. So there's a lot of trial and error in printing. Here's another one. When I first started glass bed printing, this particular part being a large part, you can see I lost adhesion on the ends. They rolled here and here, and then the print offset. So those are some of the problems I have. I have my share of problems printing just like everyone else, and the important thing is to learn from your mistakes and make adjustments and find a good, like I say, it's either a formula or a recipe for printing a part. Now, these parts are examples of testing. I'm not looking for quality here. As you can see, there's some little indications on that one showing hole sizes, where on every printer with every PLA or filament that you're using and with different settings, those hole diameters can vary. So I usually, once I get the settings good, I'll test and find out what my actual hole diameters are, and then I'll, especially for threading, and then I'll do test threads like these to see if they're right. Of course, I always check for stringing, and then when I start to print a part, before I print the whole thing, I'll print a portion of it and maybe insert a component to make sure it's fitting exactly the way it's supposed to, and I'll do that multiple times and until I get it right at different stages. You can see here I'll test and check the infill and the strength at different stages of printing. And then I always print a lot of little test parts for measurement, calibration, and just prototype parts mostly. So those are the prototypes, and then I want to go over here and show these are some finished products, and people wanted to see a close-up to try to see the quality of the print. These are not artistic parts. They're mostly functional parts, and I do like to have at least a decent finish on them, but unless you're using a glass bed or something, sometimes you're limited to the quality that you might see on these. But the important thing for me is that they're strong parts, they look good, they function properly, and so forth. Now, there are a lot of things that go into this, and one is, for example, this is a tall part, and it normally prints in this upright position. But with my experience of having more problems with parts that are tall, even like this one, I don't have a choice. It has to print in this position, and it does well. And this one, I've never had a problem with it. But just to err on the side of caution, as you might say, I changed this to print in a flat position. Now, the only change I had to make was on the back side. You can see that this hole wouldn't make any difference. I had 3 threaded sockets there. So what I had to do with this one, I had to make sure that the back of those was not flat so that I wouldn't have filament falling down into my threads. So what I did, I actually created like a pyramid roof or shape in here so that the filament in the flat position would build up to a point. And then I was able to print that one flat. This is the next part, used to also print in the vertical position. And when I went flat with it, I made some modifications. I added this for some additional accessories to lock in. But on the back side, as you notice, this one is recessed and flat. So printing in this position, the filament again would fall. And what I had to do was actually just change it to a cone or a conical type shape, which took care of that problem. So now I can print that one flat. I also did the same thing with this part. This is the one, if you remember, that I seem to have trouble with. And so I decided to print it flat. But if you notice, originally I had a slight offset here. So if I was going to print it in a flat position, I had to flatten that whole side out. So I made that one change, and now I'm printing that one in a flat position. One of the reasons that I was having this problem, and I was having it on the King Rune printers. The King Rune printers have a metallic magnetic base, which is nice. However, it does allow the parts to move a little bit if you're having problems with your filament or your temperatures, and you start getting a little bit of buildup. and it takes very little then for it to throw it out of kilter. So that's one of the reasons I made these 3 changes to the parts to run in production, and I'm running those. So I just wanted to go over that and let everybody know that this is a process of trial and error. You're going to make mistakes, you're going to crash parts, you got to do your due diligence of going through the prototyping process, and then even later on you still find reasons to redesign the part and how it's printed.